Hello, my name is Keshwani. There's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The book contains 230 problem-solving questions. It has 174 data sufficiency questions. We have already solved every single math problem from this book. If you're interested in watching any of the original solutions to the problems, you will find the original solutions from day number 1 through 250. Right now we are in the middle of redoing the problems and we are on page number 281. Please turn to it. Page number 281, the very first problem in the second column. Problem number 74. Let's take a look at it. Problem number 74. Let's see what it has to say, okay? Problem number 74 is asking us, is point R equidistant? Is point R equidistant from point -3 and 3 and point 1 and -3. Let's find out, shall we? So the very first thing we're going to do is we're going to give these points names so we can talk about them, and then we're going to plot them. We have to plot them so that we can get some idea as to what we're dealing with, so that we have some point of reference. Makes it easier to see the whole thing. So let's plot these points here. -3 and -3, 1, 2, 3, 1, 2, 3. So point A lies here, and point B is 1 and -3. 1 and -3 right here. That's your point B. This is -3 and -3. This is +1 and -3. So far so good. Let's see what they tell us in the first statement, shall we? In the first statement we are told that the x-coordinate of point R is -1. And that's all they tell us. They tell us that the x-coordinate of point R is -1. We do not know where exactly point R is, but we do know wherever it is, its x-coordinate is -1. So let's find out where that happens, where the x-coordinate happens to be -1. Well, x-coordinate is going to be -1 for this point. Doesn't matter where this point happens to be, but the x-coordinate, if it's -1, it will have to be somewhere on this line of where x equals to -1, right here. X equals to -1. This is the line. Now, having established that part, the rest is very simple. It doesn't matter now. It really makes no difference where the point happens to be. The point R happens to be on this line. Whatever it is, it's just going to make an isosceles. For example, it might be here, in which case it's going to make a nice isosceles triangle right here. The distance from R to A is going to be the same as distance from R to B, because of the fact that this point R, is 2 units from, you see, -1 is 2 units from -2, and -1 is 2 units from +1. So this line here is located right in the center. So it doesn't matter where it is on this line. If the point happens to be here, it's going to be equidistant from this distance from A to B. From R to A, it's going to be the same as R to B. It really doesn't matter where it is. It could be anywhere. The point could be anywhere. You get the idea. Even though my picture is not drawn very nicely. My picture is not drawn very nicely, but this distance is the same as that distance. So the first statement does the job quite nicely. First statement is enough for us to ascertain that the point R has to be equidistant from A and B. Because of the fact that we just established that the first statement by itself is enough, we know now that the answer A, D, B, C, E. We know now that the answer cannot be B, C, or E. It would have to be either A or D. Let's look at second statement. Second statement tells us that point R lies on line y equals to -3. Now listen, technically we should not mix up this information from the first statement with the second statement, which is not what we're doing here, which is not what I'm doing here. Because of the fact that we have a luxury of using a different color, so I'm going to use a blue color to do the work for the second statement. Line R, y equals to -3. Y equals to -3 is right here. Now, you have to ignore all the work that we did before in the red color. Just look at the blue color here. Simply knowing that the point R lies on this blue line does that tell us if that point, let's say point R might be here. Is this point, if it happens to be here, obviously the distance from point R to point A is not same as the distance from point R to point B. Or point R might be here, in which case it is closer to B than it is to A. Or point R might be right in the middle, who knows? We cannot tell. Simply knowing that the point R lies on this blue line, y equals to -3, is not enough. It's not enough. That tells us that the answer is A. The first statement by itself was enough, but the second statement was not, did not do anything. Let's move on then to the next problem, number 75. Number 75, we've got to keep on moving. Number 75 is asking us, is the positive two-digit integer n less than 40? So we have some positive integer, we are told, we're calling it n, and the question is this integer less than 40? That's all it is. We simply have to tell them whether or not we have enough information to ascertain if this number is less than 40. Yes or no, that's it. Either way is fine. Let's see what they tell us. In the first statement they tell us that the unit digit of n is 6 more than 10 digits. Unit digit is 6 more than 10 digits. Let's see what they tell us. Let's see what we can get out of it. We need to erase this thing. It's getting in the way. Let's get rid of it. We don't need it anymore. The unit digit we are told is, unit digit of n we are told is 6 more than 10. So the question is, what can we have for 10 digit? Is it possible, here's the 10 digit, here's the unit digit, is it possible for 10 digit to be 4? The answer is no. 10 digit cannot be 4 because of the fact that the unit digit has to be 6 more than the 10 digit. If 10 digit happens to be 4, then the unit digit would have to be 4 plus 6, which is 10. Obviously digit cannot be 10. Digits have to be, obviously, they're going to go all the way from 0 to 9. The highest it can be is 9, obviously. It's a digit. Oh, crying out loud. 4 is not possible. Is it possible for it to be 3? Is it possible for the 10 digit to be 3? The answer is yes. If the 10 digit is 3, the unit digit is going to be 6 more, which is 30, which is going to give us 9, hence giving us a value of 39. Unit digit might, the 10 digit might be 2. That's possible. If the 10 digit happens to be 2, then the unit digit will be 8, 6 more than that. In which case n would be 28. Unit digit might even be 1. Oh, sorry, the 10 digit might even be 1. We really don't care. It's just going to be unit digit is going to be 6 more than that, in which case it is 17. So despite the fact that there are 3 different possibilities for these integers, this integer might be 39, this integer might be 28 or 17, we really don't care. We do have enough information, we do have enough data for us to be able to answer the question that is being asked, because the question was simply, is this integer less than 40? To which the answer is, yes, we are able to tell for sure. We are definitively able to tell that it is less than 40, because the highest it can be is 39. That's all. The first one does the job quite nicely. The first one does the job quite nicely. A, D, B, C, E. A, D, B, C, E. Because of the fact that we just established that the first statement by itself is enough, we know now, answer cannot be B, C, or E. It would have to be either A or D. Let's look at second statement. Second statement tells us that n is 4 less than 4 times the unit digit. N is 4 less than 4 times the unit digit. Let's see what we can get out of it. Let's see what we can get out of it. N is equals 4 less than 4 times the unit digit. So if we call the unit digit u, 4 times the unit digit, and n is 4 less than that. That's the equation that we get out of this statement. That this integer n has to be such a way that whatever the unit digit is, if you were to multiply that value by 4 and subtract 4 from it, that's your n. What do we do with it? Well, to answer that question, what do we do with it? In order for us to be able to answer that question, we have to understand the next concept, which is where a lot of people fall in this problem, which is, what do we mean in the language of algebra? Listen very carefully. If you're weak in algebra, listen very carefully. What do we mean in the language of algebra when we talk about a two-digit integer? In the language of algebra, it's an abstract algebra is nothing more than abstract arithmetic. It's abstract arithmetic because instead of having numerical values, we have unknown quantities. So if I have a number, for example, if we have a number 37, the 7 is going to be represented by u, and 3 is going to be represented by t. T for the 10 digit, u for the unit digit. The question is, how do we write this thing in the language of algebra? How do we write 37? This is the question. How do we write 37 in the language of algebra if we did not know the value of t and if we did not know the value of u? The answer is, this is how it's expressed. We would say that n is equal to, for example here, in the language of algebra, if we had to write it, we would say n equals 10 times 3 plus 7. 10 times 3 is 30 plus 7 is 37. Now, if we did not know the values of the u and the t, or rather the t and the u, we would write this as n equals 10 times t, which is the 10 digit, plus the 7, which makes perfect sense because the 10 digit represents how many tens there are. 37 tells us that it has 3 tens, and 7 tells us there are 7 units. So 3 tens, whatever the t happens to be, 3 tens plus 7 equals n. We have to put that here. We have to equate this quantity to this quantity right here. N equals not only this part, but 10t minus 10t plus u. Here it will be u, not 7. The unit digit. 10t plus u. Keep listening, okay? Because it does get a little prickly, okay? This is the most important step. Otherwise you're not going to get anywhere. Let's bring u to this side. If we bring u to this side, what we find is that 10t equals, if we subtract u from both sides, if we subtract u from here and here, we'll end up with 3u minus 4. Now what does this tell us? This is where the most crucial step comes into this problem. Without this step, you'll never get anywhere. You will get the question wrong. What does this tell us? This equation here has a very profound insight into it, very profound information into it, a bit of information, a gem. What this tells us is that, listen very carefully, what this tells us is that this quantity, whatever it happens to be, whatever this quantity happens to be, it has to be in such a way that it has to be a multiple of 10. It must be some multiple of 10. In other words, the unit digit of this number that we're looking for has to be such a way that when you multiply it by 3 and subtract 4 from it, the result is some multiple of 10. That's all. If you understand that part, the rest is downhill. Now we just have to take our time and find out what value of u works here. Let's try it out. Can u be 1? 3 times 1 is 3 times 1 is 3, minus 4 is negative 1. Would that work? Of course, negative 1 does not work. Negative 1 is not a multiple of 10. Well, look, this quantity has to be some multiple of 10. Can u be 3? Can u be 2? 3 times 2 is 6. 6 minus 4 is 2. And of course 2 is not a multiple of 10. And we keep on going. It's just going to increase by 3. I'm not going to do every one of them because otherwise it will take forever. It's just going to go increase by 3. So after 2 we're going to have 5, then we're going to have 8, then we're going to have 11, then we're going to have 14, then we're going to have 17, and then we're going to have 20. Voila! Voila! And there is your, this is the 1, this is 1, this is 2, this is 1, 2, 3, 4, 5, 6, 7, 8. Voila! 8. Unit digit is 8. For this quantity, for this equation to hold, the unit digit for this number has to be 8. We just located the unit digit. The bloody thing has to be 8. No other value of unit digit will do here. It has to be 8 because 3 times 8, which is 24, minus a 4 is going to give us 20, which is 2 times 10, because we are told it has to be 10 times, it has to be 10 times t. It has to be 10 times t. There you go, we just found our answer. We just found out our, the unit digit has to be 8, the unit digit has to be 8, and the 10 digit has to be 2. We just located the number. the number in question here is 28. So here it turns out actually, the second statement turns out actually is even more powerful than the first statement, because in the first statement we were not able to tell what the number was. What we established from the first statement is that it's got to be either 39, 28 or 17. Second statement is even more powerful. It actually pinpoints the actual value. It tells us that the n has to be 28. No other value would do. No other value of n would do. Do you understand? No other value of unit digit will do. Unit digit has to be 8. If the unit digit is 8, the 10 digit has to be 2. Let's move on to the next one, shall we? Otherwise we'll be here forever. Just give me a second. Number 76. Number 76. In 76 we are told that the commission is equal to the fixed $300 of salary plus 5% of sales above 1,000. So we have this salesperson who works on a commission, he or she, and that person is getting paid her salary, her commission is rather, well, her salary, commission, whatever you want, is the amount that she gets paid. The commission that she gets paid is the fixed amount of $300 per period, whatever the period happens to be. Plus, she's going to get 5% of all the sales that she makes as long as they are above 100, above 1,000. The first $1,000, she does not get any commission, which is why she gets the fixed value of 300. Let's see what the question is asking. Question is, what was he paid? What was he paid? That's it. Very simple, very straightforward question. Let's find out what the tell is. This is not going to be as nasty as the last one. It's a simple arithmetic problem, simple algebra problem. It's not going to be nasty. As you can tell, it's what was he paid. It's a simple numerical work, and that's all it is. We are told in the first statement that he was paid 10% of sales. Is that enough by itself? Question is this statement enough by itself for us to be able to answer this question? What was the amount that he was paid? Let's find out, shall we? He was paid 10% of sales. So if we represent the sales, the amount of sales that he's making with letter S, then 10% of sales he was paid. But we also know that he's paid $300 fixed amount plus the 5% of the sales. But there you go. There is a simple equation we have to solve. And so there is a simple equation that we have in front of us. We have to solve it for S, and that's it. The first statement by itself does the job quite nicely. A, D, B, C, E. The first statement by itself does the job quite nicely, and therefore the answer is good. Because we just established that the first statement by itself is sufficient, we know now that the answer cannot be B, C, or E. It will have to be either A or D. Now in the real exam, we're not going to waste our time actually to figure out what it is, but here it only takes a second, so I'm going to do it here very quickly. We subtract 0.05 from both sides, so we'll end up with 0.05, S equals 300, which means S equals 300 divided by 0.05, multiply top and bottom by 100, and you will find that this becomes 300 times 100 over 5, and you divide top and bottom by 5, 100 becomes 20, and it's just 20 times 300. 20 times 300 is not what I got before. This equation is wrong. This equation is not correct actually. You see, this is why we mustn't waste our time doing this thing. Even though this equation turns out to be wrong, it tells us that we do have an equation. The point here is that we do have an equation. This equation is wrong. Can you tell me why this equation is wrong? This equation is wrong because this equation assumes that his commission is based on $300 of fixed salary plus 5% of the sales. That's not what we are told. I left out this part. It's 5% of anything that you make above 1,000. It's not 5% of the sales. It's 5% of S minus 1,000. And that equation was wrong that we just did here. It's a little bit more work here. I'm not going to take the time to actually do it. It's not necessary, is it? It's not necessary. Or if you like, we can do it. What the hell? So it's going to be 300 plus 0.05s, and 0.5 times 1000 is going to be just 50, and so we're going to end up with 350. So 0.05s equals 350. Is none of this is necessary, you understand? Oh, it's 250. You see, I made a mistake again. It's 300 minus 50. Okay, I give up. It's not necessary. We just do it out, and in the exam, this will be silly. S equals 250 over 0.05. You're going to multiply top and bottom by 100 to turn it into a 5. So you have 250 times the 100 over 5, and 5 is going to cancel out with this 20. So it's 20 times 250. 10 times 250 is 2,500. So 20 times 250 is going to be 5,000. The sales were $5,000, and then of course we can, once we know the sales, we can figure out how much he was paid. He was going to be paid 5% of 4,000. He's going to be paid 5% of 4,000 plus $300. But none of this work is really necessary on the exam. You understand? None of that is necessary. Once we have the nice equation, that is enough. That's why it's called data sufficiency. You must never be silly enough to have the urge to actually solve it. That's a sheer waste of time. Do you understand? So the first statement by itself was enough. A, D, B, C, E. Answer cannot be B, C, or E. It will have to be either A or D. Let's look at second statement. Second statement tells us that the sales were 5,000. What the hell? This is too silly. Well, if we know the sales, we can figure out the commission. Is very straightforward. Sales are 5,000, which is exactly what we found before. You see, they never contradict each other. And in the first statement, when we did the work, we found out that the sales were 5,000. That's exactly what the second statement tells us. The information in the two statements, they never contradict each other. It's never going to be the case where you do the work and you find out that the sales worked out to be $5,000 from the first statement, but in the second statement, when you do the work, it turns out to be, sales turns out to be something other than 5,000. It's not going to be the case. If that happens, then you have made a mistake. They always substantiate each other. Do you understand? Anyway, the sales here is 5,000. Of course, we can figure out the commission. Commission is simply $300 plus 5% of $4,000. Because first $1,000 you do not get the commission. The second statement is also sufficient by itself. The answer is D. The answer is D. Now the decision that I have to make at this point is, do I want to continue with the next two problems and finish the column, or should I pause the video right now? Just give me 1 second and I'll decide. Because what happens is that if I try to make the entire column in one go, the video turns out to be half an hour long. Just give me one brief second. I'm just going to take a look here. I'm not going anywhere. I'm still here. We are already up to 23 minutes into it. No, we're gonna stop right here, because otherwise it will get to be too long, because the next problem actually is kind of involves. Number 77 is not straightforward, and I don't want to do it in a hurry. I'll see you tomorrow, okay? Bye now.